Welcome to my presentation on the synthesis of polyethylene by free radical polymerization. My name is Atharva Gondikar and my teammates are Atharva Kulkarni, Sushil Shinde and Vaibhav Thengde. In this presentation, we will discuss the synthesis of polyethylene by free radical polymerization, which is well established technique for the production of high quality polyethylene products. Content: Introduction to free radical polymerization of polyethylene. Basic steps involved in free radical polymerization of polyethylene. Then initiation stage, propagation, termination stage, application of polyethylene, and last one is challenges and future direction of polyethylene. First, we know about what is free radical polymerization. Free radical polymerization is a polymerizing approach by which successive addition of free radicals take place to form a polymer unit. It is a type of chain growth polymerization with a cationic, anionic, and coordination polymerization. Free radical polymerization occurs in three steps: initiation, propagation, and termination. This method involves the use of highly reactive free radicals to initiate the polymerization of monomer, leading to the formation of long chains of polymer. Free radical polymerization is widely used in various industries, from plastic and coatings to additives and biomedical materials. Polyethylene is a widely used polymer that can be synthesized by free radical polymerization. The basic steps involved in the free radical polymerization of polyethylene are as follows. First, monomer preparation. The monomer used in the synthesis of polyethylene is ethylene, which is simple colorless gas. The ethylene is typically purified and compressed before use to remove any impurities and might interfere with the polymerization reaction. Second, polymerization reaction. The monomer and initiator solution are combined and heated to initiate the polymerization reaction. The heat causes the initiator to decompose and generate free radicals, which then react with the ethylene monomer to form a growing polymer chain. As the polymerization reaction proceeds, the growing polymer chain becomes more and more stable and the polymer chain length increases. Then termination. The polymerization reaction is typically terminated by the addition of a terminating agent such as radical scavenger which react with the free radical and stop the polymerization reaction. And final one is product recovery. The polyethylene product is typically recovered by cooling and reaction mixer and isolating the polymer by precipitation or filtration. The resulting polyethylene may be further proceed to optimize its properties for specific applications. Overall, free radical polymerization is a widely used technique for the synthesis of polyethylene and it allows for the production of wide range of polyethylene products with varying properties and applications. Mechanism of polyethylene. Free radical polymerization of polyethylene occurs in three steps: initiation of free radical, then propagation, and then termination of free radical polymerization. Then next slide continue by Atharva Kulkarni.
I am Asuro Kulkarni. I explain today initiation of polyethylene. Initiation is the foremost step in polymerization process. An active center is generated in the process to begin polymerization. All the monomers are not eligible for the initiation process. Dissociation of the peroxide oxygen bond lead to a temporary intermediate which then is quickly converted into carbon dioxide and two radicals. Radicals are transferred from the initiating molecules to the monomer unit in the second step. I am Atharva Kulkarni. Today I explain propagation of polyethylene. A polymer spends most of its expanding its chain length of propagating after initiation of free radical. It attacks another monomer subunit. It uses one of the pi bond electrons to form a stable bond with another carbon atom. The other electrons return to the second carbon atom, turning the whole molecule into a radical. The newly formed radical can add on itself by attacking another ethylene molecules. Propagating in the context of polyethylene refers to the process by which crack or fracture can propagate through the material. Polyethylene is a type of polymer which is long chain molecules made up of repeating unit called monomer. The properties of polyethylene include its ability to resist propagate of cracks are largely determined by the molecular structure of the polymer chain. The propagation of cracks of polyethylene can be influenced by several factors include the properties of the polymer itself, the environmental condition, and the presence of other material or contaminant. For example, the presence of certain chemicals or solvent can weaken the bond between the polymer chains and make it more susceptible to cracking and propagation. Thank you.
Hello ma'am, my name is Vaibhav Santosh Tengde. I explain about the termination of polyethylene. Termination is the final step of polymerization process. It involves the deactivation of free radicals. The termination occur in a different stages. If longer chains are expected, the initiator concentration shall be less, otherwise many short chains will form. Finally, the reaction is terminated when two radicals react with each other to produce the product with paired electrons. Application of polyethylene. Polyethylene is widely used in a polymer that can be synthesized through the various methods including free radical polymerization. Free radical polymerization of polyethylene involves in the initiation of a polymerization using free radicals which are highly reactive species with the unpaired electron. Application electrical insulation. Polyethylene is excellent electrical insulating property, make it valuable in electrical industries. Automotive component. Polyethylene is utilized in automotive industry in the production, agriculture sector, medical and health care. Polyethylene is used in the manufacturing of medical device such as syringe, tubing, and surgical implant. Free radical polymerization allow the production of polyethylene with a different molecular weight and properties, enabling the creation and packaging the material with desired mechanical strength, flexibility, and barrier properties. Polyethylene are used in packaging. Polyethylene is extensively used in a packaging material due to the excellent material and property such as high strength, flexibility, and moisture resistance, and pipe and fittings. Polyethylene pipes are used widely used for the transportation of liquid or gases.
Myself, Sushil Sanjeev Shinde. I am explaining about challenges and future directions of free radical polymerization. Despite its widespread use, free radical polymerization still faces challenges such as control over molecular weight distribution and the environment impact of the process. Future research aims to address these challenges by developing new initiators, improving reactions conditions, and exploring alternative polymerization techniques. Free radical polymerization is a widely used method of synthesis of polymers, offering a numerous advantages such as simplicity, versatility, and scalability. However, it also presents several challenges and limitations. Here are some of the challenges and future direction in the field of free radicalization polymerization. Control of molecular weight and dispersity. Free radical polymerization often suffer from broad molecular weight distribution, polydispersity, leading to a mixture of polymer chains with a different lengths. Future direction focus on developing new techniques and catalysts to achieve better control over the polymerization process, resulting in narrow molecular weight distribution and well-defined architectures. Thank you.